welcome back to the Kernel Platforms and OS track, the best track. And also the maintainer of the special interest group for ATune for Rob Mueller.
Thank you. Okay. Hello, everyone. My name is Donghui Chen. I'm an OpenAula ATune SIG maintainer. Today, I want to share with you the ATune, which is an AI-based automatic parameter tuning system. I will introduce ATune from the following 4 aspects. First, I want to introduce what is the performance tuning. This is a simple example for a metric multiplication of 4,800 by 4,800. If we write it in Python language, it will take more than 60,000 seconds to run. However, if we use C language to write it, it only takes about 600 seconds to run. Then, if we optimize by multi-thread parallel computing, then we can only take about 47 seconds. Then, if we use other optimization algorithms, such as the vector instructions, it only needs to take 1.99 seconds. This simple example gives me we can say that there are huge room to improve our performance. Then I will give an instruction about the ATune. As we can see, an operating system have a massive number of parameters and complicated correlations between links. However, those tunable parameters control all aspects of the operating system. For example, in Spark, there are so many tunable values. If we use the default values, they can't get the best performance. Then we want to tune these parameters. For example, there are several advantages. For example, the execution time of Spark can drop 10 times, and the system resource utilization could up to 10 times, and we can also reduce some errors, such as the OM and timeout, and so on. However, tuning parameters have several challenges. The first one is that there are many parameters in a single system. For example, in Spark, there are more than 200 parameters. Then the second one is that there are a huge number of systems. For example, there are so many applications, such as the vertical applications, analytics, and visualization systems. Different systems need different kinds of parameters. Then the second one is that there are diverse workloads and system complexity. For example, even we use the Spark, there are all kinds of workloads. For example, there are including the MLlab streaming, SQL, and the graph processing, and so on. Different workloads also need a different kind of parameters. However, if we using manual tuning to tune these parameters, there are several disadvantages. For example, it requires long tuning time and requires individual appearance and has high labor costs. However, if we use AI to automatically tuning, there are several advantages. For example, it only needs short tuning time and there is no need for individual appearance, and it only needs matching costs. Therefore, the object of ATune is that given a workload, we want to use AI to find the optimal parameters for a given workload and achieve the best performance. Now, let's see the related works. As we can see, tuning is a constant topic. In the 1980s, there are manual tuning have been used. In 2000s, statistical and heuristical methods are widely used. Recently, in 2010s, traditional machine learning methods are also widely used. Recently, deep learning and reinforcement learning methods are also widely used. The following table gives the performance of all the methods under the several dimensions, such as the quality, efficiency, and to deal with the three challenges. As we can see, there is no single kind of method performed best under all the dimensions. Now, we want to use AI to perform the automatic tuning. There are several advantages. For the first one is the full stack coverage. We can leverage a variety of technologies to optimize several layers. The second advantage is the intelligent exploration. We can explore tuning opportunities in an efficient and intelligent manner. The third one is the target orientation. We can tune the system based on objects and constraints. The third one is the full automation. We can conduct the entire tuning procedure automatically. Then we design a tune, which is an AI. We use AI enable the optimal performance of the system. First, we need to collect all kinds of data, such as the system metrics, for example, the CPU utilization, and the other data such as the framework-specific and application-specific metrics, and the target metrics. Then all the metrics are sent to the A-tune. A-tune can make intelligent decision-making and then output the optimal lobs, such as the system lobs, framework-specific lobs, and application-specific lobs. These optimized lobs can make the performance of the system better. Now we will give the architecture of A-tune. A-tune aims to analyze the resource usage, such as the computing, storage, and network of application workloads, support parameter tuning for mainstream applications in the industry, and improve tuning efficiency. The architecture of A-tune includes three parts. The first part is the intelligent decision-making, which includes online static tuning and offline dynamic tuning. And the second part is the system characterization, which includes the data platform, feature engineering, training, and inference. The last one is the system interaction, which includes the system full stack monitoring and the configuration service. Now I will give the two parts of the include the online static tuning and the offline dynamic tuning. Now I will give the detailed introduction about the online static tuning. The scenario of online static tuning is the common users and applications that need to be online at all times. The idea is that A-tune detects the current application workload, matches it to the lower workload based on the classification model, and then outputs the empirical parameters. The online static tuning have several key technologies. The first one is the important feature analysis. A-tune can automatically select important features to characterize applications accurately, and it can have two-layer classification, which can accurately identify the kernel workload. And the third one is the workload change detection. It can automatically identify the application workload changes and implements adaptive optimization. The second one is the offline dynamic tuning. The offline dynamic tuning is for advanced users who have high performance requirements. The idea is that the offline dynamic tuning includes three parts. include target device, tuner, and workloads. The idea is that the tuner sets parameters for the target device, obtains the feedback performance indicators, and iterates continuously to obtain the optimal parameters. However, therefore, the offline dynamic tuning also includes 3 key technologies. The first one is the important parameter selection. It can automatically select important parameters to reduce search space and improve training efficiency. The second one is optimization algorithm construction. It can allow user to select the optimal algorithm based on application scenarios, parameters types, and performance requirements. The third one is knowledge-based construction. We can add the current workload characteristics and the optimal parameter to the knowledge base to improve subsequent tuning efficiency. Now I will give the ATune implementation framework. The framework includes 3 parts about ATune server, ATune client, and ATune engine. The ATune server includes data collection tool and system configuration engineering. The ATune server must be installed on a target device. The ATune client is used to interact with user and output the results. The ATune engine includes all the algorithms of ATune, such as the classification models, k-parameter selection models, model training, and the automatic parameter tuning. The 3 parts can be installed on different machines, and they can communicate through the gRPC. Now we will give several tuning results. For example, in Spark, there are several tunable parameters. If we use the default value, they can't get the best performance. Then we want to use ATune to select the best values for the given workload. For example, after the ATune tuning, the performance is improved by 30% over the default system configuration and 5% over the configuration optimized by professional engineers. The tuning efficiency is 5 times that of manual tuning. Now, there are also several other tuning results. For example, we optimize the etcd system with ATune, increasing performance by more than 10%. The results were displayed in the OpenAULA application porting competition. And we also optimize the MySQL. MySQL is optimized in 6 different scenarios on OpenAULA, and that operates with virtual machines with 4 cores and 60 GB memory, as well as 32 cores and 64 GB memory. In the OLTP insert scenario, the throughput is improved by 5 times. In the future, ATune will break performance bottlenecks. There are 2 kinds of improvement. For example, we want to from offline to online. There are several trends. For example, continuous performance tuning capabilities for online application to deliver performance as a service. For example, there are also several systems. For example, AllTune provides online parameter tuning for cloud databases, and the Graduate focus on resource queue tuning for online applications. However, there are also 3 challenges. For example, the first challenge is the cold start. How do we deliver optimal performance in the absence of history data when a new application goes on? The second challenge is the adaptability. how can the cost of online training be reduced when a model is trained against online applications load that changes dynamically? The third one is security. How do we keep the performance of the intermediate tuning results above the preset threshold to ensure high system availability during tuning? The second one is from user mode to kernel mode. There are also several trends. For example, utilizing AI technologies to shift from conventional system configuration optimization to system design optimization. There are also several papers. For example, LinOS uses AI to reconstruct the kernel block layer and predict I/O latency, boosting SSD area performance. KML is another paper which builds an AI model in the kernel space to implement load-aware data prefetching policies. However, there are also three challenges. The first challenge is the computing overhead. How can model complexity and performance be balanced with the limited computing resources available in the kernel space? The second challenge is the timeliness. How do we infer and execute the highly dynamic optimization policies in milliseconds? The third one is the universality. How do we construct a universal framework for different optimization types that involve data collection and optimization algorithms for various kernel modules? Here is the Attune repository. Everyone can get the code of Attune. Please feel free to contact me if you have any questions. This is my email. Thank you.
Any questions? Any more questions? Okay, then thank you, Dong. Okay. So next up is Qingxiao Liu, who has more than a decade of experience in cloud infrastructure, more than 6 years of experience in container technology. He is principal engineer at the OpenEuro project, and he will tell us about a redesign of the process one called SysMaster. And it's all in Rust, so it's super relevant.
Thank you. Okay. Oh, let me try. Yeah, it works. So, welcome everyone. Today I will introduce you another one, process one. Yes, we are writing a new process one for OpenEuro, and it is written with Rust. Okay. Its name is SysMaster, and we open sourced at OpenEuro. OpenEuro is the new OS platform. We already open source it at Git and GitHub. Okay, is currently incubating at OpenAtom. Okay, right. So today I will go with these 3 parts. First, why we want to write a new process one, and second, what it should be, what it should like, and how we'll design and its architecture. Before that, what is the process one? Process one, actually, in our Linux OS, there is the process called process tree. Okay, it's like the tree. So the first process, that's process one, is the root of a tree. So it's the first user space process in Linux, and all the other process are its ancestor. It has 2 main roles. First one is brings up the whole system. Second one reads the other soon-be processes. So in a process tree, its stability is very important. That means it affects the whole reliability of the Linux OS. Oh, but before that, we already have many process one in the whole operating system world. Okay, currently we have counted there are more than 20 process one. In very different OS distribution, we have such as systemd, upstart, sysinit, and launchd. Normally in Red Hat OpenSUSE, we use systemd, Ubuntu, Debian, we use upstart, okay, and we found that there's some difference, and we also talked about that in different US, we have different process one, which means that this is because the demands or what this OS we want that demands on the process one, what it looks like. So before that, we talk about OpenEULA. And OpenEULA, we are trying to build one OS for versatile scenarios, includes cloud servers, edge, embedded devices. Or we have to analyze all these scenarios. The first one, in traditional servers, according to our statistics of our maintenance and SRE team, we found that we have a timetable here. For the last 5 years, we have many bugs in process one. Okay, it accounts for 16%, and these bugs stands long for the past years. It's still high every year. And the third one, nearly 1/3 of bugs are memory-related bugs. Okay, that's really harmful to the maintenance team. Okay, and as we said before, its reliability is very important to the OS. Once it has any bugs, to need to recovery or need to restart process one, it causes the whole OS to restart. Okay? It is very critical. So we need this process one as reliability and has the ability to self-recover. That's the traditional servers. And second, in cloud native, in our current world, especially many of our virtual machines applications are just managed by Kubernetes or OpenStack, which means in the perspective of our SRE, they have to handle many different management platforms. But Kubernetes and OpenStack, they cannot manage those system services in the OS, which means we're trying to provide another agent in the OS in OpenEULA to connect to the Kubernetes and OpenStack for easy maintenance. And the second one, currently in the container world, many of us, we are building the container OS like Firecracker or such as. And in this container world, most of apps are containerized. So we don't need a huge process run anymore. We hold this in this container OS. The process run is as small as possible. So we want this process run is part of Kubernetes or OpenStack ecosystem and reliable, small and reliable. Embedded system, embedded devices. The traditional process run is huge to use in an embedded system. And the normal process run in embedded system, they don't have a service management to manage those system service. So we want this process run is lightweight, small, and have the ability of service management. That's all our scenarios. So we want this SysMaster is ultra lightweight, high reliable, and one process run can cover for versatile scenarios of OpenEULA. Okay, and then it has the full monitoring and self-recovery mechanism for its reliability. That's our vision. Before we were trying to write our first code, we decided that which programming language we were using, C, C++, Golang, or Rust. And last we choose Rust. I think the first thing is it's really growing fast. And it is also emerging in our fundamental software. It is also accepted by Linux kernel last year. Okay, and that's the first thing. It's very famous and popular. And the second thing, Rust, it is features for security and high performance. That is what our SysMaster wants. So we choose Rust for our programming. Next is our design. We talked about it before. In SysMaster, we hold it is ultra lightweight, small, reliable. So we decided as 1 + 1 and plus n. The first one is init. It is the real process run. It is as simplified with only klock. And the second one is core. Only provides the core functions of service management and self-recovery. It should support live update and hot restart, and don't affect the running of OS. And the other key system functions will be plugged by the other models, and they can easily combine with those one and one. This is like Lego. In Chinese, we call it 榫卯. These two Chinese words. Okay, and this is after our design. And the first one, it's init. It is the real process run. It needs to read zombie process, brings out the whole system, and also monitoring is SysMaster core. It is also, currently it is only less than 1,000 lines of code. When it is running, the whole code is only 400 lines. It is suitable for the embedded devices, and it is really, maybe really reliable. Currently, it is down. And second, the core, SysMaster core. It provides the important self-recovery mechanism and also the service management for those system service. It is added a reliable framework. It currently supports the hot restart and live restart level update to improve those reliability. And we decided in two cases. The first one cases is once it is running to handle the daily routine when it crashes, and then it self-recovers. And the second scenario is it is trying to call or to bring up the other apps. At that time, itself or still crashes, and then it try to self-recover. We have done it, and all this during this period, the whole OS and services are running properly. We have a small demo here. We can show you later. Okay. Next, its extensions. As we said before, it has a design as 1 plus 1 and plus n. Yep. And we introduced it, the init, the core, and the other all key functions will combine with this extends. And those important system functions, we call it is consists as logout. Okay. Currently, we have finished the dev master. This device dev master will provide this function as device manager, and currently it is working. We are building out it. And in the near future, we will bring out the bus master and unit master for other kind of system functions. Okay, a small demo. Yep, no. Yep. Here, he's my colleague, and he's trying to show. He has many. He's using the process one, the system master running. Oh no, now it's. Oh, I'm going back. At first, it is learning it within a container, a systemd container. Within the container, there's a systemd trying to bring out many system service in the container. Then it learns it starts a server at this window and trying to start up the systemd service here. Okay. Yep. And start up it. It is running its systemd, and okay, try to bring up the service. And then we will see that there's receiving requests. Then you try to set a signal ball, a signal 6 to this function, and then it stops. Okay, and this is shown with systemd that this service is queued by signal 6 signal ball, and then we can self-recovery. So next, we'll try with sysmaster. Then you can see that sysmaster will try to self-recovery. Okay. Yep. Learning with sysmaster now. Try to bring out the test service. Yep. Ping again. Okay. Try to kill it again. there's something wrong, but it's still running. Yep. It's working fine in the system container. Okay. That's my show for today. Okay. Thank you.
Still got 5 minutes. So, any questions?
So this is a alternative alternative service, thing, right? Alternative to System D, is it?
Near future, because as you well, last year we released the Clay version 0.1, and last year we only and I have devices. Yeah. As you know, in D it supports many functions. It provides many.
Yeah, it does.
Currently in our master, he only trying to build up more functions in the
Oh, so it's still in development.
and welcome to join our community.
So, any more questions? Okay, then thank you very much. Test. Okay, so welcome back, everybody. Our next talk is from Katie Lee, who is a manager of the community operations of T-Thread. She has more than 6 years experience in that, and she will tell us about an IoT operating system development for the light smart age. Enjoy.
Thank you, House. And a huge thank you to the FOSSASIA to bring us here as an open source project. We very much appreciate the support here. I'm Kathy. I'm working for open source Atos, Artifra Atos organization, and I'm helping with the global community operations. And my talk today is talking about the Internet of Things operating system development under the light smart age. Well, most of you may already know that we are calling the light smart RTOS-driven smart devices as the light smart RTOS, light smart driven RTOS. RTOS, here we are talking about the RTOS, it's about the real-time operating system. And RTOS, because of its features like hard real-time, low power, fast startup, low cost, it's more likely to be used in the smart home, smart world, industrial control, and smart cities for both the NPU power devices and MCU power devices. Nowadays, we are defining what should be like a perfect RTOS to be chosen for a project. We feel that the RTOS at this moment it should be presenting as a platform to support a wide range of components such as GUI, audio script framework, network protocol, POSIX API, AI framework, and make it up for grades to help developers to quickly get started with the IoT and embedded system. Well, at the age of the lightweight and smart, we feel like that the RTOS is more demanding than ever before, both from the ecological side and technical side. And it requires more features. It requires more features and both from the POSIX API, the chip support, the software ecosystem, the learning resources, the CPU IP, the tool chains from the eco side. And from the tech side, it's more about the components, software packages, IDEs, the MMU support, the security, the high reliability, and a lot of more features. So, well, today I bring the Artifra RTOS project. Artifra is an open source real-time operating system that was born in 2006. It was generally generated as a kernel, and we started this project from 2006. So there are some milestones I'd like to highlight about the Artifra project. By 27, we released the Artifra IoT OS, its Internet of Things operating system. And by 2020, we have the Artifra Smart microkernel operating system. It's all open source for community developers. So, technical side, there are 3 versions of Artifra available. One for the Artifra Nano, Artifra Standard, it's for the IoT operating system, and another for the Artifra Smart, the microkernel operating system. Well, we will start from the Artifra Nano. The Artifra Nano maintains a simple kernel with less than 5,000 lines of code, and the resources consumption can be as low as 3 KB flash and 1.5 KB RAM, and it has high reliability that has been applied to the field of electricity industry, the consumer electronics, and a lot of more. So to get you better understand the Artifra Nano, it's just a simple kernel. Yeah, to compare with FreeRTOS. So for the Artifra standard version, because when faced with the complicated application requirements, kernel is never enough, so we create a platform. The Artifra kernel, the components, and a lot of more models has been integrated into the Artifra platform. So, and based on the Artifra platform, we introduced the Artifra software packages. Till now, we have more than 600 software packages contributed from the community, and some of them from our teams. And those packages cover in the IoT, security, AI, language, data, and a lot of more. So the Artifra Nano is a kernel, but the Artifra Standard is a kernel and has a lot of components and the software packages. Well, along with the development of chips, AI computing, edge computing, turning into the direction of the terminal devices, the demand for running a the okay sure the demand for running a lightweight real-time operating system on the chip with MMU, we call it memory management unit. For Cortex-A and RISC-V60 is gradually increasing. So we put forward our new offer, the Artifresh Smart. It is based on the Artifresh kernel, but it isolates the user space and the kernel space. It is more like high security as it isolates the kernel into the user space and the kernel space. Well, there's some highlight about the Artifresh components. We got Finch, we got your log, your task, system view, and a lot of more. The RISC-V, ARM, and most trending chips are all supported in the Artifresh platform, and the community and we put a lot of efforts to make this happen. Yeah, Artifresh supports the GNU, GCC, IDR, MDK, KO, and a lot of more IDEs. Also, we home built ourselves Artifresh Studio. Artifresh Studio is a 1.0 and free to use IDE that we created for the community developers to help them get quickly with the project developments. The Artifresh Studio IDE supports the simulation function. So even if you don't have a hardware platform on hand, you can still use the Artifresh Studio IDE to get started with the work. Yeah, and the Artifresh software ecosystem plays a crucial role in the Artifresh platform. Until now, we got 600 software packages covers in application files such as IoT, communication, security, multimedia, and so on. Artifresh has been favored as the most powerful RTOS in China with the largest installation. Now, till now, we got power 2 billion devices, and we built a community with 150,000 developers participated. Here are some highlights about the Artifresh community events, as we believe the power of the open source is the power of its community. Yeah, we also have our university program. Artifresh opened the Artifresh courses in over 100 universities in China and outside of China. And we built joint labs in over 55 universities. And we also hold more than 2 online and offline teacher trainings per year. Also, we're sponsoring some contests and sponsoring some program in the university. So we welcome universities and organizations to join us. Also today I bring an AI kit that we create for the university students. Do I still get time to show? Okay, sure. The demo will be shown outside of this event hall. So if you have any interest, just check out with us. Some event highlights. Okay, that's pretty much some highlights about the Artifresh project. If you have interested about this open source project, welcome to connect with us on the social media platform. And by the way, I'd like to mention that we are going to hold the 2023 Artifresh Global Tech Conference on June 1st to June 3rd. It's online and free, open to all the developers. Welcome to join us. Thanks. Any questions for Artifresh project? All right, so maybe we can check out.
Thank you. Next up is Jens Petersen, who is an engineering manager at Red Hat, works on Red Hat Enterprise Linux, Fedora, internationalization, workstations, and Haskell. And he will talk about containers and toolbox. Enjoy.
Thank you very much. Thanks for coming to this talk about toolbox containers. Yeah, as introduced, I'm Jens Petersen. I work at Red Hat for quite a long time on OS development. It's great to be back in person here. Yeah, so just to motivate a little bit about, so I've been using these toolbox containers for quite a while. I just find it really nice to have my sort of development environment is completely separate from the system environment, so I can choose to upgrade when I want, or I can use an older system sometimes if I need something there. Yeah, so today I'll mainly be talking about two projects which I've contributed to, but I'm not the main developer. I just want to say up front that I'm not taking credit for this. But so one is Toolbox, another is DistroBox. They're somewhat similar, but they also have some slight differences. Yeah, as we'll see. Yeah, so what's a Toolbox container? Basically, it's just a so-called pet container, which means it's something that you're taking care of that's maybe is valuable to you. Something you might be using for a longer period of time. And yeah, so it'd be using Podman or Docker. And the special thing about it is that it has access to your home directory and desktop environment and system resources and so on. So yeah, but I mean, obviously the environment in the container is different from the system environment usually, or well, it doesn't have to be. You might want to have install packages which you don't want in the system because you don't want to mess up your system, but you just want, yeah, you still need those tools or applications. So I'm going to approach this these four fundamental questions: why, how, what, and who. So let's start with the why a bit more. Yeah, so I think I more or less covered some of this, but so yeah, there's two main use cases. I mean, originally the Toolbox project came up in the context of OS tree operating systems where you kind of have an immutable operating system, but then it's a bit awkward to like have development tools and so on in that kind of environment. So then you'd have a Toolbox container where you could install your compilers and IDEs and so on. Yeah, and also another advantage of toolboxes compared to say using a VM or something is that it's a lot less resource intensive, so you can save memory and disk space and so on. Whereas a VM might need 10, 20 gigabytes to run in. A toolbox container will just share memory with the system and also disk space and so on. So yeah, it's quite good in that sense. So I'm not really going to go into a lot of detail because it's a very short talk. But yeah, so basically they're just, especially under Podman, they're rootless, privileged user containers. And then they're using like namespaces and bind mounts to bring like sockets and system directories and so on into your toolbox. And so usually it's a sort of two-step process. First you create the toolbox and then you enter it, or you can also run directly from your host shell. But so yeah, so today I want to demo this toolbox and also DistroBox, which are the two main projects which are kind of for sort of interactive graphical environments. So first, yeah, there's Toolbox. which is now kind of hosted in this containers org on GitHub. So it was originally started by Debashi Ray in 2018. Originally it was just a shell script, but then it was rewritten later in Golang. The idea was that Golang would bring it closer to Podman, and most of the container tools and so on are written in Golang. So, though I think in practice it's more just calling out to Podman these days. But so yeah, it's packaged in Fedora from the beginning, and also available in RHEL and Arch, and also it's available in Debian and Ubuntu now. Yeah, and I guess one of the differences between Toolbox and DistroBox is that Toolbox requires custom container images, so it kind of assumes that certain tools and, well, some minor files are in place, unlike DistroBox, which can use standard distro containers to build its toolboxes. Yeah, so in Fedora we have this Fedora toolbox image, and which I also help to maintain a little. And also in RHEL we also have a toolbox. Yeah, this is the UBI, but there's also an official RHEL toolbox container. But then in last year, the community kind of got tired of waiting, and so yeah, various people, also some at Red Hat, helped to create this new repository for other operating systems. So now there are a lot more toolbox containers available for lots of different distros listed here. So that's quite a nice development. Yeah, so maybe I can show a bit. So I have a shell here. So this is actually a VM running on my laptop, and yeah, and let's see. So here's a list of. I should make it bigger. Yeah, you can see that there's various toolbox images here, like for CentOS, Ubuntu, Fedora RHEL, and I've got a few. So let's try to enter one. Okay, and you see this little box here at the side here in purple. It says just to show that it's a toolbox container. So yeah, I've actually, well, for example, on my host system, I don't have Emacs, but I installed Emacs over here, so I can, oops. I actually have the source code here too, but anyway, so that's, what else can I show? So, perhaps I'll move on to, well, actually I could, okay, I can show one more. It's an Ubuntu toolbox, so yeah, it's, and, yeah, I can do something. yeah, so that's running the Ubuntu inside this Fedora system. Yeah, and so I have access to all my home directory here, and as you can see, yes, I could install some graphical application and run it. All right. Let's move on to DistroBox. Sorry. This is nice graphic. So this is a community project started in 2021, and it's all. I think it's originally it was a port of. Okay, thank you. Of the Toolbox shell script. So it takes a bit of a different approach. Like I said, it doesn't need custom images. It supports quite a wide range of distros, probably more than Toolbox does. Yeah, there's, so we can see this. It's a file here. Yeah, this is the distros that it runs on, I think, and also, you can also see where it's packaged here. Sorry. I think OpenSUSE is also using it. So it also supports Toolbox containers, so you can use like this repository I mentioned earlier of the Toolbox containers. And then, yeah, there's lots of different distros that are supported. So that's quite nice. Yeah, and it has some other nice features. For example, you can set a different home directory. So if you're worried about interfering with, say, your home directory files or something, then you can create a DistroBox toolbox which uses different home directory. It also has some other good things. It has, for example, dry run option, which will show you like the commands that are, like the podman commands and so on that are being run. It also has support for kind of ephemeral or short-lived toolboxes, so you can just start up an ephemeral toolbox, test something, and then go out again, and it will just disappear. So that's quite good. So yeah, I think Toolbox is good for developers, also testers. I often use it. I often want to compare something in one version of the operating system with another version, or if I'm debugging something, I want to check if something's fixed in a newer library, things like that. Also, it can be used, say, particularly on, say, OS trees for sort of system troubleshooting as well, where maybe some tools that you want are not available in the system, but you can then put them in a toolbox and run them there. Yeah, so that's really the talk. Yeah, the projects and my contact details. Happy to take any questions you may have.
Hello, thanks for the presentation. I saw that you opened a GUI version of Emacs, right? UI version of Emacs. So my question is, can we run any UI, any GUI without complex configurations like in Docker? Like, can we open browser or anything easily in Toolbox? Anything? Okay, so no complex configurations required for that. Okay, thank you.
Any more questions?
Thank you. So by the help of this distro box, okay, and there will be the new image of OS. There is only one kernel and the process one. Then any other distros is with distro box. Okay. I think it's interesting. And I have another question is, because we talk about the container OS, like core OS, yeah, and the OS is read only. So when we debug, we will install a debug container. Yeah. What kind of tools we will install in this debug toolbox, and is it suitable for the maintenance on live network? We have, or just is it suitable for use for the SI team, like this way? Just put all the debugging tools in this container. Is it okay? I think I want to hear some advices from you.
So yeah, you're right. The kernel, yeah, so the toolbox depends on the system kernel. So there can be issues with certain, one issue is like with drivers and so on, like GPUs and things like that. So ideally it should have the same, ideally the distribox and the kernel should kind of be, for the same kernel. And also there's no system D running in the containers, so that is a problem. Like some services may not work in the toolbox, so that's a limitation. As for the troubleshooting, yeah, to be honest, I haven't done it a lot myself, but yeah, for example, even the Core OS is moving to use Toolbox. They previously had their own kind of simpler Toolbox. But yeah, I don't know, it could be like some debuggers or network, I don't know, troubleshooting tools or something. Yeah, it's a good question. Thank you very much.
Is there a demo mode or background mode in Toolbox like can?
So these green toolboxes are still running actually, even in the background. And another thing I didn't show is that you can, you can also run applications from the host. I mean, via toolbox, just using this run command. One other thing I forgot is the DistroBox also allows you to export desktop files to the host desktop. Yeah, so you can like see. I think I had one example. This GTK demo. It's not very exciting, but it's actually running in a DistroBox container. If it does. There you go. Yeah.
More over there.
Hello. So I just want to ask one question. So how my understanding is that container you need a process keep running like PID1 or something that so that the container stays alive. Looks like on your case it's staying alive because you can do it. So how that is being handled, and is it being recommended? How can we spawn up multiple processes? Is it recommended to do like we can spawn up multiple processes? Like how we can handle that?
Right. Yeah, good questions. Yeah, I mean, system D is running on the host system. There's also something called conmon, which is kind of a container monitor, which is sort of works together with Podman. So it checks that the container is sort of continues to run. And yeah, you can run multiple processes within one container. It feels like just a normal like shell or other desktop environment. So you can have multiple processes running there. Yeah, you can if you want. Yeah, I mean, I usually have toolbox running in the foreground in my shell. So yeah. There's also integration in this GNOME terminal, so that if you create a new tab, it automatically starts up in the same toolbox that you're already running. So yeah. Any more questions? Thank you very much. Thanks for your attention.
Okay, next is Parth Goswami, who is a customer enablement engineer at Cloudera, who will tell us about CNI plugins and IPMA.
Hello, everyone. Hope you are having a good summit so far. Good evening to you all, and a very warm welcome to all the attendees joining this event virtually. I am Parth Goswami, and today I'll be trying to highlight some of the open source CNI plugins and their approaches towards IP address management and container networking. Now, before I start my talk, I wanted to highlight that networking is one of that aspect in the container or maybe even cloud computing that is often overlooked, maybe because of various maybe it can be a bit complex topic to some of the folks, or they might be scared I mean, towards the networking part for various reasons. So this is one attempt to make it a bit simplified, and I'm going to give a very high level overview about the topics and concepts that we are going to touch. So the approach that I'm going to follow today is, so we are going to talk about adapting open source CNI plugins for IPAM. We are going to start with understanding in brief what CNI is. We'll touch the topic about plugins, what exactly plugins are. We'll try to understand what IPAM is, and then we'll focus on the need to adapt the open source CNI plugins. All right. So the textbook definition given by Cloud Native Computing Foundation about CNI is that it's a specification that defines how to configure networking for Linux containers. Now, it does that by providing a set of APIs for networking solutions to integrate with different container runtimes. Now, if you take a look at the pic over here, there is container runtime of your choice, and then the CNI sits on top of it. And within CNI, it ships lots of components called as plugins. Now, what exactly these plugins are? So before we take a look at plugin, let us try to understand a bit more about what exactly CNI does and how it does whatever it does. So for example, if I need to establish a network within a container, I need to have its own network namespace. So I create a network namespace. Now, once I have that, I need to create a bridge between the host network namespace and the container network namespace. Once I have the bridge, I create a couple of virtual Ethernet pairs. Why virtual? Because we are dealing with containers and not like virtual machines or physical hardware. So any Ethernet, any networking component that we will be dealing with is going to be virtual. So we create virtual Ethernet pairs, and then we attach one end of it to the networking namespace and attach one end of it to the bridge. And once we have that, we finally assign the IP address to uniquely identify that pod, and we bring up the interfaces. And this is how the interface comes up and the pod goes live. So this is a sample kind of algorithm, sample code, sample program to achieve certain steps, to achieve a certain desired result. Now, this exact same requirement is there for almost any other container orchestration, RKT, Docker, Mesos, Kubernetes. So why not we kind of create a standardized version of it and then try to ship it with any other orchestration. So the very thing of creating a standardized version of it, creating kind of a library of it, is called as a plugin. So so before we move on to plugin, let's try to understand that if we want to create our own CNI, what it must do, or what are the absolutely most necessary roles that this CNI should perform. So I don't want to bombard you with a whole lot of theory. So I'll just highlight a couple of points from this must-have roles. So it must be able to create a network namespace, as we just discussed. Then it must be able to identify the network of the container, and it should be able to deal with the bridge. If we are adding container or deleting container, then it should deal with one of the output format. It must support command line arguments so that we are able to fire the commands and interact with it through our CLI. It must be able to manage the IP addresses, which is the exact topic of this talk, and it must return the results in one of the desired output format, JSON, text, tabular, whatever it is. So if any CNI is able to do some of these roles or majorly all of these roles, I think that would be a pretty good thing. Next. So what we have seen so far is the textbook definition provided by CNCF of what CNI is. Basically, a plugin is a collection of program or a code. So here you see a few examples of plugins such as loopback, bridge, PTP, Mac VLAN, IP VLAN, and then there are many third-party plugins as well. So so examples of third-party plugins that is being adopted or that has been accepted by Kubernetes is Calico is there, VivNet is there, Flannel is there, Cilium is there. So just to give you a brief introduction about all these third-party plugins. So Calico is a popular CNI tool that deals around network security based on cloud-native architecture, and it is mostly used in the enterprise version, enterprise-level environments. Flannel is something that is simple and lightweight and very easy to install, but it is mostly preferred for small scale clusters and not something that is larger in size. Then we have VivNet. It is into providing network automation and observability features. And then we have Cilium that is basically based on the identity-based access solutions. So these are all open source CNI plugins, and since they are not maintained or developed by CNCF itself, they are third party. Now, let's try to understand what exactly IPAM is. Now, here I'm not touching IPAM from the Kubernetes or from the containers point of view. I'm just talking about the simple plain IP address management. So basically, it means that if you are doing something which falls under assigning, monitoring, tracking, or managing IPs, you are kind of dealing with IP address management. So it's not that you have a device, either virtual or a physical device, you assign an IP address and you just go about it. No, it's not that, because at your level, at an individual level, you're dealing with just one device, but at an enterprise level, you are dealing with huge clusters, which might have thousands of nodes, and it's a combination of nodes, virtual node, physical node, etc. So you need to have a proper procedure set, a methodical system, which will define how your assigning of IP address will work, how the tracking of IP address is working, whether the device is, if it is not in function, whether the IP address is being revoked or not, it should not be reused. So all this mechanism needs to be there properly being set and defined. So that is basically what IP address management is, and it is basically an integrated suite of tools. And it also like encompasses the concepts of DHCP and DNS. Next, now with respect to Kubernetes, what exactly IPAM is? So Kubernetes also relies on IPAM. Since Kubernetes mostly works at the cluster level, it needs to manage or deal with thousands and millions of containers, pods, and it requires those many IP addresses as well. So there is no option for Kubernetes to skip IP address management. So it requires IP address management, and it definitely relies on it. Now Kubernetes has its own inbuilt tool to manage IP address, that is kubeproxy, but definitely that comes with certain limitations. Now before that, in Kubernetes, each pod will require its own IP address to talk to each other, to talk to other pods, to talk to services, and to talk to external network. So if IPs are required for so and so reasons, then the addresses need to be managed. Kubeproxy is something that is actually handling the IP address management, but the limitation is it can't scale. So it works fine, it works efficiently to a certain extent, but once you cross its threshold. I'm not sure about what that threshold is, but if you cross it and move to a very large, complex cluster, or maybe a very complex topology of network, then kube proxy seems to not work efficiently. So that is the main limitation of the current by default IPAM plugin that Kubernetes has. Next, so then there are some challenges presented by IP exhaustion. So basically what IP exhaustion is, back in 1980s when we came up with this concept of IPv4, it was divided, it is divided into 4 blocks of 8 bits each, 32-bit. So back then everybody thought that this many millions of IP addresses or billions of IP addresses would be enough. But then within 10 to 15 years, by late 1990s, it was very clear that those many IP addresses would not be sufficient, because it is not about an IP being used by a single user. It is about an IP being used by a single device. And it was very clear soon enough that a single person would need or would require multiple devices. So in our day-to-day life, we at an individual level, we carry phone, we connect our laptops to VPN, we have a number of devices. So each and every device at any point would have at least 2 to 3 IP addresses. If you just check about the Ethernet that you have, you would see the number of IP addresses being consumed at the individual level. Now just extrapolate it to a scenario where you are running enterprise level clusters, and you would understand that the need of IP address is actually a very complex issue, and it's something that needs to be managed very efficiently. So this causes IP exhaustion, and there are some problems or some challenges that is presented by IP exhaustion. The first is network congestion. Now since the IPs are getting exhausted, the pods in the Kubernetes cluster would compete to have the same IP address, or compete to have the IP address from the same pool. And that might result in network congestion. That might result in potential downtime or maybe service interruptions. Now, that can be a resultant factor in network congestion. Then there is security risk. If IPs that we are adding or the IP addresses are exhausted, it can be tempting for the network administrator to reuse the IP address. By reuse, what I mean is, if there was an IP address that was assigned to a pod, the pod gets killed or whatever, the IP gets released to the pool. Now, before the IP was properly released, the admin ends up using it or assigning it to a new pod. So that might lead to having the live access to the previous pod's sensitive information. So that poses like a sensitive, like a security risk. Next is difficulty in scaling. Since my pool itself has, for example, 100 IPs, and my cluster demands 500 pods or 1000 pods, that definitely would not allow me to do so. So if IPs are getting exhausted, my cluster would not scale the way I would want it to be. And then increased complexity. In case of IP exhaustion, if my pool itself is having less or limited number of IPs, the network and admins would be tempted to go for much complex solutions such as NATing, or maybe like go for overlay networks, such kind of complex solutions. So there are much more challenges by IP exhaustion. So let's see what can be done about it. Okay, so this brings us to the main topic, that because Kubernetes uses by default kube proxy, and kube proxy comes with its own limitation, hence there is a need for the Kubernetes itself to adopt open source based CNI plugins. Now there are various third party CNI plugins in the market, in the market space that approaches IPAM differently. So let's understand what exactly the limitations of built-in plugins as of there is. So there are a couple of plugins, host local and DHCP. So host local plugin assigns IP address from a predefined pool. This approach is good for smaller cluster, but once we go at a bigger level, it will surely cause problem. Then DHCP IPAM assigns IPs to pod using DHCP IPAM plugin. It can be good enough for a large cluster, but it needs an overhead like a DHCP server. So again, we don't want such an overhead. Now, one of the AppM or one of the third-party CNI plugin that I have been working on and used is Calico AppM. It is a completely open source plugin, and it has certain key features that because of which it is being widely used as one of the most sought after network plugin. It uses distributed IPM architecture, meaning for every node there would be a separate and specific IP pool, not at the cluster level, but at the node level. So this ensures that the IPs can be assigned or allocated to the pods residing on that node very efficiently and quickly. And it doesn't need a centralized server, unlike the DHCP IPM, since the IPs are allocated at the node level and not the cluster level. It doesn't require a centralized server. And if the local pool itself gets exhausted, um, it, it, uh, it can request for more IPs from a central pool managed by Calico IPM controller itself. Next, Calico IPM supports network using BGP, Border Gateway Protocol. This allows network admins to segment their network into different subnets. Now this segmentation can come from the request by the application itself or from maybe there are some security concerns that needs the segmentation. So this allows the network admin to enforce some traffic related policies. Then it has support for network security such as policy informant and encryption of traffic between pods. So these features ensure that the cluster is compliant with industry standard along with handling the management of IP addresses. Yeah, so that was all about the topic. And if you want to check out more about this Calico open source or how Calico approaches IPAM, or if you wish to contribute more to this project, just check out its GitHub repo. And there is also a program being run by Calico called as Calico Big Cats, where you get to meet the maintainers, the developers on a monthly basis, and you can just try to understand more about the project and be involved at a very deeper level. So this is the recap. We saw about what CNI is, what IPM is, what plugins exactly are, then what are the current challenges faced or presented by IP exhaustion, how Kubernetes is dealing with IP management and what are its limitations, and what features or what solutions third-party open source plugins such as Calico present. So yeah, so that was all about it. And I'm Parth Goswami. I work as a uh, customer enablement engineer at Cloudera, and also I'm a Calico community ambassador. And that is my community platform where I regularly write blogs and share my open source stuff. So yeah, thank you. That's it. Any questions?
Do you think there will ever be a state where containers can be scaled to zero on the networking stack and sort of be activated on connection?
I'm not sure about that. So from what I know, the IPs are being allocated at the pod level. So pod would definitely have the IP address, but whether it would continue working in spite of containers or not, I need to check about it. Yeah.
Any more questions? Okay, then thank you again. Okay. So next up is Sachin Shobe. He's a solution architect for DSA and an expert on multi-cloud environment. And he will tell us how AWS security works internally.
Hi everyone. How many people are working on cloud? Working. Very good. On AWS? So good. Remaining are my audience. I have a good number of people to tell about. Okay. Uh, part of this portion will be, we will only take how you log in into AWS, okay, how you access AWS service. We will not talk about the authentication authorization for the applications and all that thing. It will be only to AWS, okay. When you create a AWS account, okay, you have a privilege to create an organization out there. Organizations can be assumed as any organizations where you have multiple departments. So you can make an account as organization. So that will shift into management. And the remaining you can add for each, you can define it depending on the organizations, how exactly they take AWS into their day-to-day activity. They can, for each department, they can have a separate accounts, okay, or for specific product, they can do internal bifurcations where they will have accounts and all the associate service will be linked into it, or resources and service out there. Okay, to better manage, use OU, which is the options out there where you can define in OU that this specific account will be used for example, XYZ project or for the department, and you can do that. Inside the OU, you can have multiple account. Best example for accounts are environment, dev, UAT or prod, which you can do out there. So when you create an account, okay, there will be two things which you have to do. First thing, the account which you have created, it will be a root account. When you create a root account, okay, the standard advisory is to don't use an individual's account. For example, for XYZ reason, he leaves the organizations, you will have trouble managing that specific AWS account. So the best advisory is you create a generic group and a generic mail ID and create that account with that. For example, if it's a project and it's for the dev environment, the dev, then project name, and that mail ID. So create accounts based on that. So when you create account, there are two things. You can, when you create, you have to always create with the ID, which is given by AWS. but you are given a provision to give a proper namespace for that. So you can change the name as per your convenience out there. Second, when you create account or root account, once the root account is created, you can create users, you can create roles, you can create policies, as well as if, for example, your organization which you already have users out there. I think I went to the next one. Oops. Yeah, it's there. You already have a user out there. So in this case, you can integrate that specific users inside AWS. We call it federated users. You can have a requirement where your activity will be done by certain application. For example, a Lambda, that will be representing or working out there. That is one thing. Any service which go and authenticate, when you go to any applications, you give your username and password, that become a user. In AWS term, we call that as a principal. A principal will be the person who will be approaching out there. Okay. In IAM, you can have principal as a user. For example, any employee of your organizations or any individual like myself, if I create an account, I will be the first user. Second will be a role. You can define a role and assign that role and work on top of that. Third, the federated, just like if you have a Google account, you can integrate with Google out there. If you have a Facebook, you can integrate with that. Most organizations use Active Directory, which is the common for most of the organizations to work out there. Fourth is applications or Lambda functions, where you can use them to authenticate and work on resources or the current buzzword automations out there. Why you want to access their account? To use AWS resources. Okay, so there are multiple resources in AWS which you can use out there, which can be EC2 instance, which you can use. It can be S3 bucket. It can be database, RDS. It can be S3. There can be multiple, all the services and applications provided by AWS you can consume out there. When you are consuming out there, you want to authorize out there, authorization out there. What you want to do is what permissions should that specific resources should have, how exactly or what privileges you should give and utilize out there. Okay, that you do with the help of policies. So when you define policies in AWS, there are multiple ways of defining policies, but we will be covering majorly 4. One is identity-based policies, which will be the user, the principal which you have created. This principal, it can be user, role, or federated, or applications. We can define, give the policies out there. Second will be, these are limited. Resource-based policies are very restricted for certain resources, just like S3 bucket, which is also allowed to be accessed from internet. You can deploy a static website with the help of S3 bucket. So such specific cases, we can use S3 resource-based policies. In case of DynamoDB, you can also use resource-based policies out there. Third is permission boundary. In case of permission boundary, what you exactly do is, for example, I have been given a role to be to manage my department. I should not have privilege to go into other account or other department and start accessing out there. So by default, there is permission boundary. If you are given a permissions, you can maximum give the permission to your department. If you give permission more than your department, okay, AWS will block it. The fourth is service control policies. Service control policies is more about restricting, or we normally call as SCP. In SCP, we define this in AWS organizations, where we define this specific account. For example, it's a dev. So when developers are working on it, you want to scope them that they can only use low-end resources. They should not start consuming high-end resources. There are probability, you might be knowing or not, one of the developer have, so there is, when you are accessing, you can access with username password, or you can use the access key and access secret. One of the developer have checked in the ID and the secret on GitHub, which have been used by other user to hack and do the Bitcoin mining, and will have went into very high. So, so that's where one of the reasons you should scope, or there is other way of managing it. You can have billing where you can have monitoring on top of that to restrict out there, but as part of security, it doesn't come out there. So there are, as we are managing AWS, we are managing AWS two ways. One, when we go to AWS website and log in and work, we call that as AWS Management Console. Second, via CLI or via API. That is called as via code, when you're programmatically accessing out there. So when you are accessing from AWS Management Console, it's called action. When you are using CLI or using SDKs, we call that as operations. Once we create account, okay, as we see in the organizations, that we can create accounts for multiple accounts. From one account, we want to try to access another account. We have to build a trust relationship between them. If the trust is not built out there, you cannot make connection to that account and work on top of that. So if anybody have worked on AD or any authentications out there? So from, yeah, at least one. So from one AD, if you're trying to access other AD, you have to build at least one-way trust. If you build one-way trust, you can have the access of the other AD and get the information, same out here. If you are from one account trying to access other account and want to perform actions on top of that, you have to have a trust relationship out there. So if you see the red dots, that's highlight out there. So what we have discussed, now come to a real case, okay, where there will be, when we create a AWS account, we will first have principals. Principal will make a request to access certain services. When the requests happen, we will go to the authorizations, which will check what policies does this current user have. Does either the policy will be or identity-based policy or resource-based policy. It will also validate whether there is CSCP applicable on that specific resources. Do we have to restrict that? Do permission boundary applicable to that specific resource? Yes or no? That comes authorizations. Next part is what action you are going to perform. Right? Are you just going into that? You are going to create a EC2 instance. Are you going to create a custom RDS? Do you have the privileges? So when you come to action, when you're requesting that I want to create a EC2 instance, it will check whether you have the policies to perform that actions or not. Okay. So you are making an actions to specific resources. Check whether the authorizations is there based on the user. Second is, when you are working in organizations, you will have multiple accounts out there. Each account will be linked to the other accounts. And my God, I'm very fast. Here comes question answers. You can drop in, I think. Voila, 15 minutes. I'm fast. Yep. Questions? Okay, no questions. Thank you. Everybody here.
Okay, so welcome back. Next up is Priyam Sahu, who is a software developer for Red Hat, who works on Ansible. He will tell us about the language server protocol and all the nice things you can do with it. Enjoy.
Thanks a lot. Okay. So yeah, I am Priyam Sahu, and I am a software engineer working at the Ansible DevTools team from Red Hat India. So for the next 10 to 12 minutes, I'll be talking about what actually a language server is and how does it actually work. Then we'll take a look at the fact that why do we need a language server today? And now, and after that probably I'll just show some steps so that we can learn how to build our own language server. Finally, I'll conclude, and just before concluding, I'll just give you a code walkthrough and a small demo of a small language server again. So yeah, what is language server and how does it work? So a small question, have you ever imagined working on a code editor that does not understand the programming language you're working on? Probably not, because today, as the complexity is increasing, we cannot imagine working in a code editor that does not provide auto-completion for us, maybe linting for us, syntax highlighting, hovering, go-to definitions, etc. And all these features that I explained are known as language services for a programming language. Now, traditionally, what used to happen was someone had to develop an extension for a programming language per code editor to support that particular programming language in that particular editor. And you can imagine how time consuming it is, and to support different editors, one had to repeat the same underlying logic again and again, but with the different APIs, because every tool provides different APIs. And this is where language server comes into picture. Back in 2015, Microsoft, along with Red Hat, came up with the idea for the language server protocol. What actually is a language server? Language server is basically a tool that provides all these language features in a decentralized manner. There's this tool, those are the extensions which can directly communicate with the language server and can give you the results. This is a clear example that shows that. This is the first example that explains how this thing works without a language server. Basically, if I want to support Python for VS Code, Atom, and Vim, I'll have to develop all the three extensions for these three editors. But now what happens is, with the language server, if I want to support Python, I would just need to create one language server, and all these three tools would have tools or libraries that would communicate with the language server, and there you go. You get all the language features. Now moving ahead, just a small introduction about how this particular thing works. So we have our development tool, that is the IDEs and the extensions. And the other hand, we have the language server basically. Now when the user opens a document, a notification for did open is sent to the language server. And when the user starts typing something or starts editing editing a text document, it sends a notification called did change. And now let's say we want to provide diagnostics when user starts writing. So now the server sees that the diagnostic provider has been registered in the did change life cycle. So it analyzes, creates the diagnostic reports, and sends back to the extension. The same goes with the go-to definitions, the auto completions, and the hoverings. Now things would be much more clear when I show you the code. So I'll just proceed. Yeah, now before moving further, just wanted to clarify some differences. There are three terms: language server, the language client, and the language server protocol. Basically, what is the language server? As I explained, this is the tool where you define all the language capabilities and write the logic, and basically write the logic for the providers. What's the language client? This is the code editor that communicates with the language server and leverages the services. The language server protocol, that's the set of rules that governs the communication between the server and the client, which is basically based on the JSON RPC request and response mechanism. So yeah, now comes the important question. Why do we actually need to learn language server today? So obviously the very first 2 points are clearly if you have your own custom programming language or a scripting language, you would definitely want to create a language server for that so that other people can use it with ease. The second is, again, if you are working on a code editor and you want to support some important programming languages, just go get an extension, build an extension that could communicate with the existing language servers. But for the last 2 days, I was there in FOSSASIA, and I have just recently noticed a lot of you guys have developed projects, and almost all of them require some sort of a configuration file for that project to work. And this is where I find the importance of language server comes into picture. For example, you're working on a project and you need a set of configuration files that the user needs to type in so that he or she can actually work on that project. You can actually write language features particularly for that particular config file so that the user will be able to easily adapt to the configuration settings and can work accordingly. And for this part, I'll be demoing this particular example with the Ansible config files. Yeah, let's quickly go ahead and see how you can build your language server. Basically, first of all, choose an SDK. You don't need to rely on the internal workings, how you send a notification, how you receive a notification. You don't need to know that. Just go pick an SDK, and there's a huge set of SDKs that are available. You can just go and based on your programming language, you can choose one. Next, choose the tool. For example, if I want to develop an extension, I would go ahead and use the VS Code tool, and I would like to, and I will start the development of the extension. Next, structure the project. While starting the language server, it's very small, but as you grow, the code complexity increases. So it's a very good idea to structure the project. And then finally define the language capabilities in the server, and in the client side, it's just a matter of initializing the server. This is how I like to structure the project. I have a client, I have a server, and the extension.ts is the place where I initiate the language server, and now comes the server part. We have a server.ts file. This is where I actually push in the provider logic at a particular event cycle. And then I have providers like completion provider and the validation provider. List can go on. The definition provider, hover providers, etc. And then some utility files, if you have some. Okay, now we'll move to the code, and I can show you some good stuff here. So let me switch to the VS Code, and here. So initially I was talking about the event cycle. So this is how the event cycle works. So we have something called connection.onCompletion. You just register your logic for the completion provider in this particular piece of code. For me, it is do completion. And then there's again an event cycle called as onCompletion resolve, where I would like to return do completion resolve. Particularly do completion and do completion resolve are my custom functions that I've created and the logic that I've written over there. Now there's something known as on did change. Let me find that out. Yeah, on did change. And as I said I would like to validate a particular document when something changes in the document. So I just call validate text document on this particular part. And this is how the code is, and that should work. And just a small demo. So we have an Ansible config file over here, and this is how it looks without the language server. It's very hard to identify if there are some mistakes or not. And if you want to type something, we actually don't get a feedback, and I don't know what could go inside this particular section. But now we'll see this with the language server. Now the language server is activated for this file, and I already can see some results over here. The first squiggly line says that, yeah, this is an unknown option. So I need to verify that. And I know it's debug. There you go. This is correct. And this says there's an unknown option known as tag. I need to correct it, but I know it is tags. I'll do this way. And now to demo some auto completion. When I am inside tag and I start typing, it tells me there's no suggestion. That means I have no other options available here. But inside default, if I come and start typing, I get all the available options inside default. And now what's even interesting is it is context aware. After a gap line, if I ask for auto completion, it knows that this is a section. And there you go, the completion works this way. And now when I'm in Jinja, I know there's one option particularly in that particular section, I get the auto completion here as well. So this is how the auto completion works. And yeah, probably I will end. And before concluding, I would just like to add one more small thing over here. Yeah. So how successful is a language server basically? I can tell you the success of this because I am the author of the Ansible language server and the VS Code extension. And within the past 1.5 years, there have been around 330 plus K downloads in the marketplace and 46,000 downloads in the Open VSX repository. Talking about the language server particularly, there's already Ansible extension made for the Emacs and the NeoVim editors using our language server. So this is the power of open source, and I hope in my presentation I was able to convey the importance as well as it could act as a starting guide for someone who would like to develop a language server. So thank you. Any questions? Yeah.
Yeah, hi. Very nice session. One question though, how are multiple versions handled? Like say as an example, I have version 1, the way, and say in version 2, there is some feature which is removed. Okay, now again, that change will need to reflect in the language server, right? Like, even for my usual development as an example, okay, some syntax was valid for version 1, but is no longer valid for version 2. So how are the versions controlled?
So there's nothing fancy that is going on over here. For example, if I can understand correctly, while using this particular thing, I have something called as, where's that? Let me find that out. Ansible config options. Let's say in the new version, I don't have this particular option for me, agnostic become prompt. It's just a matter of fact that I would need to remove that particular thing from here. And that's how you don't need to change anything. But if you develop your code in such a way where you have one single source of truth for all the facts that the language server can particularly use, you just need to modify that particular file and the rest of things would be taken care of. I hope this answers your question. Thank you.
Anyone? Meeting your hero. Okay, then thank you again. The last talk of the day from Robert Chen comes from Con, is a solution engineer there, and he will tell us about Kubernetes Gateway API and how this is different from Ingress. Enjoy.
Mike test. Hey, hi everyone. You might have seen me in 2 days ago in Kubernetes meetups. I was saying the same thing, but if you are not, please stay, okay? Because after this, I'll ask you guys and girls a few questions. I'll give you some swag, okay? I got approval from the organizer, so we're gonna give you something. So just stay, right, and try to learn something a bit how actually Kubernetes Gateway API and Ingress can help you in your platform delivery. All right. Okay, a little bit on myself. I won't spend too much time. Robin, a sales engineer based in Singapore in Kong. So previously, I'm like everyone like you, right? I started working in software engineering, then DevOps, and then you do everything, right? You work in startup especially. So happy to be here and invited for the talk. And the key thing that I want to give everyone is actually how this Gateway API can help you in terms of your Kubernetes deployment. All right. So some agenda, I'll just give some recap, some technical overview, some demo. If the network don't die, actually it's my phone I tethering, so I better take out, right? Because the Wi-Fi here is not very nice. Okay, and the last part, Q&A, quizzes, around 3 questions. You can answer my question. My colleague sitting there will give you a pin, and then after that you'll be redeemed with a swag from Kong. Okay, so this is something we want to share to the community here. All right, so recap Kubernetes Ingress controller. So what is it? I think there's so many talks the past few days. You deploy something EKA, AKS, you probably heard of it, or you might have used it and you might not know, or your platform engineer have already provided for you, right? So what is Ingress controller in the Kubernetes clusters? Right, Ingress, okay, the best way that I can say is like your front door where before I come out, I need to go to the booth and register, right? So Ingress controller is kind of the front door to check in all the incoming requests to your clusters before they consume the service, and then do the necessary routing, right? So it's something like a load balancer, if you talk about that. But to layman term, it's just a front door to see, okay, Robin, you should go lecture hall 2.1. You shouldn't go 2.2. That's not your speaking slot. Cool? Okay, so that's how it actually works in the Kubernetes world. Not much differences. Yeah. Okay, that's how we typically deploy all this Ingress controller to direct all this traffic when they come into our cluster. Okay, very simple. Huh? So Kong itself, we have our Kong Ingress controller. So I think if you deploy, you have been using some of our other Ingress controller like Nginx, right, and some others, right. So we have our own implementation. Basically the same thing, okay, just that we add on with some of our Kong features, like some of the API gateway feature that I don't want to talk too much about, right. I want to keep it a bit more generic and open source today. So that's where our Ingress controller works, where you come in, then do redirections, etc., and also enhance with some of our plugins, API authentications, OAuth, all this, right. So this one I won't go in much into detail, okay. So why we want to change the Ingress, right? We are creating Ingress object easily, creating service. Why we want to do that? Why this gateway API was introduced? If you went to the KubeCon like 1-2 years back, why was it introduced as an experimental right now? Okay. So currently Ingress support all this path matching, host matching, easy, right? TLS routing, load balancer implementation. You create an EKS and get a ALB up, simple. Okay. But then again, we realized that we need a bit more advanced usage of our gateway APIs. Advanced use cases that the Ingress doesn't support. Okay, that's where Gateway API come into the picture, right? You can do header-based matching, header manipulation, traffic splitting example, 50% new service come up, which I'll demo later. How can you ensure that only 50% of your incoming traffic go to the newer service? How can you do that using that kind of routing? Okay, the Ingress actually don't do that. Okay, so that's why Gateway API come to the picture to do that kind of complex, a bit more advanced use cases. Okay, there's some other extension like other routing protocol, gRPC, TLS. Okay, so what I said, you try to read a bit because I'll ask you a question later. Okay, so other routing protocol like gRPC, I emphasize again, and also custom resource definition for other backends like proprietary protocol. That's a possibility that actually this Gateway API want to achieve. All right. So quick example, right? I think it's better to illustrate with some not cartoons, some pictures and some word. Okay, so we have a company. We have usually Alice Box Cairo, very typical security 101, right? So I mean a lot of you are actually doing all these 3 things. You create a infra, you create a cluster, all the Kubernetes admin and application developer. So I think you just start, especially do everything. So just think of this, the 3%. What's your role in the Gateway API implementation? Okay, so gateway API implementation, there's a gateway class. Right, so infrastructure provider like Alice, for example, they actually the one that actually define the gateway class from the provider, right? So for example, ACME.io, it could be your Kubernetes, AWS implementation, application load balancer, network load balancer, Azure application gateway, GCP, etc. Right? So or F5, etc. So this is based on vendor specific. Okay, so I'm the one that actually create this for my cluster admins. Okay, I can be someone like that. Okay, then we move on to gateway. This is where the platform cluster operator come into place, right? The CKE, Kubernetes administrator. And then this is where you will define the kind of gateway you want in your cluster. So you have that external gateway for external LB, and then exposed to maybe only port 80 or port 443, depending on your needs, okay, to receive that kind of traffic. So when you create this, right, if you put in maybe a cloud provider like Google Cloud or AWS, you spin up a load balancer coming and then listening to port 80. So that means my traffic can only come into port 80, right? I only can come to that door, right? So that's how it works. So this gives Bob, the kind of cluster operator, that flexibility to create external LB, internal LB. Why is it important? Sometimes your cluster need to serve internal, external traffic, or some kind of specific traffic that certain load balancer that can address. Right? So this gives more segregations and responsibility on the kind of setting that you want. And then the route is I think something that resonates with a lot more of you if you are working with dev, right? Like when you create a service, your microservices, you deploy your CI/CD, you want to create your Helm file, and then create a Kubernetes method. That's where you come into place, right? How do you want to expose your services, right? Like matching, create a path so that external people can use. So all this is where it comes into place. Okay, it's not very different from how you do an ingress object. Okay, but you can see that there's HTTP route, and just like I mentioned, another route, gRPC route, blah, blah, blah. So give you a lot more flexibility. Okay? So I think the question is how it helps, right? I think existing API, it's like the ingress already covered simple use cases, right? But I think from what the school of thought is actually gateway API try with things like the day 2 operation when you want to do upgrades and management of the cluster, right? So how it helps. So consistency, like the infra provider like Alice, right? They can keep their gateway class of manifest consistent. Maybe only the vendor they change. Maybe from AKS to AWS to Azure or SH or vice versa. While there's also allowed them to have a fixed set of parameter reference here. Okay, so parameter reference can be things like I just go a bit networking, your subnet mask, your internet IP, all this. You can define it consistently across different gateway classes. Okay, so this gives them a bit more control on how they can reuse this kind of gateway classes templates. Okay, then if I'm a Bob, I want to upgrade to my new load balancer. Maybe because like for example AWS classic load balancer, I want to change to network load balancer, right? I can typically just change the gateway class implementation that I actually fix here already, right? So I actually fix here, then I can just change the gateway class name through there. So all my ports, all these, I see the ports 80, listening port 80, port 443, whatsoever. I don't need to change. I just need to change the naming of the gateway that I previously updated. Okay, and so you can see that flexibility you can do, and then you don't have to recreate your Nginx or Kong or what, or reinstall the manifest, everything. You don't have to do that anymore. Right. Then the last thing I think is very beneficial for developers, right? Especially when do the kind of blue-green deployment. Very simple thing. You have your new service version 2. You want to only let 10% of your internal employees to access, right? You can just put a weightage for like 1. Okay, 10%. So every 10% of that in the traffic will go to the newer service. So they can test, and then when it's all ready, right, then you slowly toggle to the weight to maybe 100 or something to the new Acme store canary for the newer service. So you can do that easily using this gateway API. Okay, so this is not proprietary by Kong, right? This is what actually gateway API can actually achieve when whichever ingress controller implementation you do if they support this. Okay, HTTP route is an open standard. I just emphasize that. Okay, so some concept before I go for a demo, right? I just time check. I talk a lot. Okay, so I think this is pretty straightforward. Gateway class, gateways, HTTP route. I think this I mentioned already, so I don't want to regurgitate. Okay, this one I also mentioned already. So yeah, just read the routes. Okay, HTTP, TCP, UDP, TCP. In case I ask you a question. Okay, this you just have to remember it. Okay, all right. I'll do a quick demo on this basically I'll install a gateway, I'll do a splitting into 2 services, right? And then that's it. Okay, let me do a quick demo on that. I think I don't stand better. All right. So see my VS Code, right? I got the mouse here. It's working. Okay. So see my VS Code. Actually, I will share the slide. So this is my sample demo repo, right? So let me just show you a quick one. So what I did is I install gateway. Okay, this is quite standard. Just install gateway and then the gateway class. And then I have 2 deployment, 2 service, one HTTP and watch HTTP. Okay, I already installed already. And then next I will actually create a HTTP route. And what I do is I will do a toggle 50-50. So you see 50% echo and 50% HTTP. Okay, so I could do a quick demo on that. Okay, let me make it bigger. So there's 2 services here, and now I'm applying the route. Okay, the route is applied already. Now let me try to consume the service. Okay, I'm very lazy, so I will copy and paste my command. Yeah, I think developers are all like that. Oh, okay, question 1. I want to ask question already. Why my request is not found? You are sharp enough? Why my request is not found? Want to try? Yes, please. See, he's listening. The Gui, can you help me? Yes, you're right. I didn't put a header. Okay, this is very ingress related. Okay, great job, you are listening. Okay, let's see now. So you see that my header, I'm expecting person and then Robin so that I can get. Okay. So see, the first one is echo. I put another one HTTP bin. You see the toggle? It's the same route, same host. Okay. So it's sometimes 50-50. So you can see the magic of this using a basic HTTP route toggling. It's just this. 50-50. So app developer, easy for you, right? You don't have to think of writing logic to your code to redirect this. All this is Kubernetes, open standard. You can do that easily. All right. So this is a very quick demo. Okay. Okay. So yeah, this is what I just showed. So I won't say too much. And additional route support. Remember this TCP, gRPC, UDP. So remember. And this is how you can actually enable the gateway API using Kong. Okay, I'm not sure about other implementation, but the slide I shared to the organizer, so I think you can download. So all this information are there. So basically, this gateway API in Kong is still in experimental. You need to enable the feature gate. So you have to enable and to use it and see if you got any feedback and send to the Kubernetes user group, not to me, which Kong is sitting inside as part of the committee to actually do that. Okay, quiz. Ready? First one. Can I do traffic splitting in gateway API? Yes, our friend from API 6. Give him, yes, he know it. Okay, you cannot answer the next question already. Give chance to other people. Okay? I think your implementation also can do. I think you're still in beta. I didn't really see. Okay? So name one Kubernetes ingress controller implementation that support gateway API, which I've been talking for the past 15 to 20 minutes. Organizer can show you know. Okay, what I mean, where you come from? Well, yeah, open up your raise your hand. Whoever said, okay, this gentleman. Give him. Yeah. Okay, yeah. So okay. Kong is one of the many ingress control implementation. I think API 6 do that in also Nginx. So this is just a way to support on that. Okay. Last question. Is it possible to support gRPC route? Raise your hand, gentlemen. This bro. Hey, yes, you are right. Correct. So typically you do Kubernetes ingress is always HTTP route, right? Then and also maybe some flavor do TCP password, but eventually want to support more modern protocol routing like gRPC, etc., so that you can support your new use cases. Okay, so and this is a quick promo code for our education. You can take a picture. So if you happen to be using Kong, you want to upskill, please use this promo code to get some 100% off to offset your certification, because this is actually you have a proactor and you do the test like your CKA AWS, right? So it's a proper certification. And then we still have education that can go up and sign up for free. Maybe I send in a tagger or something, education at Kong or something. Then they can actually sign up your self-paced learning. You can do that free of charge also for the one-on-one courses. All right, then thank you for your time, for staying, and hope you learned something, and thank you for inviting me to the talk. Happy to hear that. Any questions? I'm done asking, so any question for me? No question. Sorry? Yeah, ask question also got swag, you know, so it's easy, right? Easy thing. But don't ask me personal question, that one no swag, sorry. Where I come from, Singapore, yeah, that's very... Yeah, any questions on, yeah, like how can ingress control help? I mean, not just Kong, right? It can be Kubernetes, which I know a fair bit, AWS. Okay, no questions? Yeah. I don't think so. Service mesh address a separate thing. Service mesh is address explosion of microservices. So imagine you have 1,000 services and you want to everything do a Kong up down. That would be a spaghetti architecture. No, I don't think so. It might address like you have small microservice a few, but if you talk about a lot of microservices, like more than 100, and you want to manage that kind of interconnectivity, then a gateway is definitely not even gateway API or any API gateway is not the right solution. Okay, that's my take. You can do that, but will be there's a lot of complex routing you need to actually adhere to. But then again, service mesh capability do overlap with some of the gateway API. Like this kind of gRPC route, using Envoy, right? Automated TLS, all this, right? So it really depends on you. But no, I don't think so. And just to highlight that, actually, gateway API is not replacing your current way of ingress API. Okay, no plan to replace it. Both address different thing. Yeah, I see. So they say cannot replace. You see, God is saying that. Right? Okay, so no. You still use your ingress, you won't die. Okay, your HTTP ingress you're using well, continue to use it. Okay, no need to rush to use gateway API. Okay, just give you a bit more flavor on that. All right. So whoever got a pin, please go to my colleague and redeem a small T-shirt from Kong, complimentary from Kong. Hope you take one only, not everything. So just take a T-shirt for the pin. You will see us again. Happy to join any meetup, open source meetup or FOSSASIA next year or something. We can have a lot more talk on that. Thank you very much, guys and girls. Thank you.